Today we're going to move into Chapter 8. As I mentioned at the beginning of the unit, we're covered a couple sections from Chapter 5, and we're going to cover some information in Chapter 8. Chapter 8, this first section, we're working with Pythagorean theorem again. We're also going to be working with its converse. And with the converse, what we are able to do is just extend it a little bit. When we did that face activity, we could use Pythagorean theorem to say if it was a right triangle or not a right triangle. By using its converse, when we say it's not a right triangle, we're going to be able to take it a step further and say if it's an acute triangle or an obtuse triangle. So you still using that idea of Pythagorean theorem. So if you're at that flap that says, can a triangle be formed? This is something that we talked about earlier in that first section, so that 5-6. Okay? So remember, again, for it to be a triangle, we know the sum of the two shortest sides must be greater than the longest side. Okay? So when we look at these three problems, for this first one, we've got 3, 6, and 9. Are we going to be able to form a triangle with those sides?
No, because they're equal.
They're going to be equal. 3 plus 6, 9. 9 is going to equal 9, so that one's a no. So remember, if they're equal, it's a no. What about 7, 4, and 5? Yes. We're going to get 9 when we add the two small ones. What about 2, 3, and 8? No. So that's how we know whether or not we can actually form a triangle. Once we know we can form a triangle, then we can use this information. So for this one, says if the square of the length of the longest side of a triangle is less than the sum of the squares of the lengths of the other two sides, then the triangle is acute. So when we look then, if you open up that acute triangle piece, okay, the key thing here is writing it with the c squared on the left side. We're so used to when we say Pythagorean theorem, we say a squared plus b squared equals c squared. Okay? Which when they're equal to each other, it doesn't matter what's on the left, what's on the right. Okay? For it to really make sense in your brain with the acute and the obtuse, we want to have that c squared on the left. Okay? So if the c squared is less than the a squared plus b squared, then it forms that acute triangle. Okay? So when I'm thinking about acute and obtuse, okay, acute is the smaller, obtuse means we have that greater than 90 angle. Acute is smaller. And that's why we think of the less than, okay, which only is going to match acute if you have your c squared on the left. Okay, so we're always going to put our c squared on the left. Then that less than makes sense that it's going to be with acute. So it says, can the following sets form an acute triangle? Okay. Need to look, again, your C always has to be the largest number. I'm just going to put those in order. So C squared, okay, C is square root of 5. I need to square it. Okay. I don't know if it's going to be less than or if it's going to be equal or it's going to be greater than. So right now I'm just going to put a question mark there because that's what we need to figure out. And then I have the square root of 3 squared plus the square root of 4 squared. Now I need to work it out. What is the square root of 5 squared? It's 5. The square root, squaring a square root, those cancel each other out. So we just have 5. So the same thing happens on the other side. We have 3 and 4. So what symbol is going to go in between? It's going to be less than. Okay? So yes, it is going to be an acute triangle. For this next one, biggest side has to be the C. So I'm just going to put them in order. So C squared, so 22 squared, question mark, 11 squared plus 17 squared. So then we need to show our work. 22 squared is 484. 11 squared, 121. 17 squared, 289. So what's 121 plus 289? Nine plus 1 is 0, carry a 1. 8, 9, 10, 11, carry a 1. 4. So 484 is greater than, okay? So here, is it acute? It's going to be no. Okay? We're going to learn in a minute that it would actually then be an obtuse. Okay? So, Pythagorean theorem, you need to show your work. Okay? Some of you did not do that very well on your face activity, and that's why you lost points. Okay? Because you wrote this and then you wrote your final answer, if you even did that. Okay? That's not showing your work. You need to show your work step by step. So, Pythagorean theorem. Okay, we've worked with this multiple times. We know that if the sum of the squares of two sides of a triangle is equal to the third side, then it is going to be a right triangle. Okay? So it goes both ways. If we know it's a right triangle, Pythagorean theorem has to be true. Or if Pythagorean theorem is true, if they are equal, then it has to be a right triangle. So again, when we're looking at this to be able to decide if it's right, acute, or obtuse, we want to get in that habit of C squared being on the left. Okay. So if we just always put C squared on the left, then it's going to help us out. So again, I've got my A, B, and C. So I have 5 square root of 2 squared, question mark, 5 squared plus 5 squared. So when I square 5 square root of 2, what am I going to get?
Well, so doesn't the radical sign and the exponent cancel each other out?
Okay, so it will here, but we're squaring this whole thing.
Yeah,
So that's 25 times, it'd be 25 times 2.
Okay. So, a couple ways that you can think about this. Okay. You can, when we square something, that means we're taking it times itself. So on the outside, 5 times 5 is 25. On the inside, we get square root of 4, which is 2. And 25 times 2 is 50. Okay, so you can process it that way. Or if you remember exponent rules from algebra, this exponent has to go to the 5 and to the square root of 2. So 5 squared is 25. Then we said the square root and the square cancel each other out, so we get a number 2. So again, 25 times 2 is 50. We had some of those again on that face activity that we did. 5 squared is 25. So for this first problem, they are going to be equal. This was a typo. That should say right triangle. That's what we're talking about. So this is going to be a right triangle because they are equal. When I look at the next one, I've got 27 squared, question mark, 11 squared, and 25 squared. 27 squared, that's not one that we need to memorize, but we can multiply it out. So 729. What's 11 squared? 121. And 25 squared? 625. So when we add those together, we get 746. So this is less than, so it's not a right triangle. Because it's less than, we know it is an acute triangle. And then this last theorem, the option we haven't looked at yet. So if the square of the length of the longest side, so my c squared, is greater than the sum of the squares of the other two sides, then it is obtuse. So again, that's why we like to have that c squared on the left, because when I see a greater than symbol, it makes sense for greater than to be obtuse, for less than to be acute. If we had the c squared on the left side, or I'm sorry, on the right side, then it would be the opposite. A greater than would mean acute, which doesn't make sense. All right. So again, we've got our 3 side lengths. So we plug it into Pythagorean theorem. 10 squared, question mark, 5 squared plus 5 square root of 3 quantity squared. So we have to square that whole thing. 10 squared is 100. 25, or 5 squared is 25. So what's going to be 5 square root of 3
I've got 60.
squared?
Yes, sir.
Okay, so we have to square the 5, which gives us 25, and we square the square root of 3, which gives us 3. So that's a 75. Okay, so these are equal, which means it's a right triangle. Okay, so it's not obtuse, it's right. This next one, we have 22 squared, question mark, 12 squared plus 19 squared. What's 22 squared? 484. 12 squared, 144. 19 squared,
360.
Yes, 361.
361. So if I add those together, 4 and 1 is 5, 4 and 6 is 10. So I get 504. So it's less than, so again, it's not obtuse, it would be acute. So still using that idea of Pythagorean theorem, we want that c squared to always be on the left side, so that when we see a less than symbol, it tells us acute. A greater than symbol is telling us obtuse.